advanced math topics. As always, GED Live is brought to you by the GED Testing Service and Kaplan Test Prep. And I am Kaplan teacher Rachel, and I'll be working with you through this lesson. So let's go ahead and take a look at what the topics are that we'll be covering. In this lesson, we're going to focus on really three main broad topics. The first is systems of equations. Okay, and so we'll take a look at systems of equations and how to solve them specifically using algebra. Now, you may be aware that it's possible to solve a system of equations also by simply graphing them and by looking at a graph and figuring out, oh, where is that point of intersection? So that in particular is covered in the coordinate plane session, because that's where we cover graphs and actually drawing out the lines. So some concepts from coordinate geometry we will touch on in this session. So you may find that you're more comfortable if you review coordinate geometry and then come back to this session. Just a heads up about that. And also, as to the PDF for the session, we will be using it, and I will be referring you to the PDF in this session. So if you haven't already downloaded that or printed it out, you might want to get your hands on that. But I do have a workaround for you if you don't have that handy and it's not easy for you to get it right away. So we'll be covering systems of equations, again, with a little bit of math that comes from the coordinate plane session. We will be looking at various types of equations and formulas that involve factorials. So that does include your formulas and your calculations for combinations and permutations. So we'll talk about the difference between them, when you use them, how you use them, and how to use your calculator to make those calculations nice and easy. And finally, we'll focus on some three-dimensional geometry. So 3D figures, right? So we're going a little bit beyond what you covered in the geometry and data analysis session, in that we'll be adding that third dimension. So making the problems a little bit more advanced, although with 3D geometry, it all comes down to just applying a formula. And as long as you know which formula to apply and what each of the variables stands for in the formulas, you're going to be good to go. So we'll demonstrate that in the last third of today's session. So let's go ahead and dive in with systems of equations. So a system of equation is, as it says here, a set of two or more linear equations. And so a linear equation is an equation that describes a line. It's an equation that has two variables in it most of the time. So most of the time on the GED, you're going to see a set of two linear equations, each of which has two variables in it. And we're going to look at, again, the algebraic ways to isolate or solve for one or both of those variables. So if you have two equations, chances are you will have two variables and you'll be able to solve for each of them. Now, there can be more advanced systems of equations that could have quadratic equations where you have, say, a squared term, or inequalities or other types of nonlinear equations. But the vast majority of what you see on the GED math test will be linear. So that's what we're going to focus on. So when it comes to these linear equations, you can solve them by graphing, as I mentioned earlier, or by algebra. And again, solving by graphing is something that is covered in the coordinate plane session. So definitely check that out if you're not certain how you would go about doing that. So what does it mean when we solve a system of linear equations? Well, if you have linear equations, again, they do describe lines, and the solution is the intersection of the lines. So the solution is a point on the xy plane. The solution is a point, and it's the point at which the lines intersect. Now, interestingly, when you have a system, if someone tells you to solve the system, you're like, okay, great, I'm going to find a solution, right? And a solution in this case would be an x value and a y value. However, it's possible for a system of linear equations to have no solution. You're like, oh, what does that mean? Well, given that the solution is the point at which these lines intersect, what if they never do intersect, right? What if these two lines just keep on extending forever one right next to the other, or they could be further apart, or they could be closer together. But what if they never ever meet? Well, how could that happen? You can see by looking at these lines, and this word may be popping into your head as to what property these lines have with respect to one another, right? How could you compare these lines and say, oh, these lines have the property of being parallel? And again, thinking in terms of the coordinate plane, that means that they have the same slope. So two lines that have the same slope are never going to intersect. They're always going to just go along next to each other forever and ever and ever. No intersection means no solution. Now, you could have more of a standard situation, which you're very, very likely to see on the GED math test, and that's a situation in which there's just one solution, right? So two lines, they meet at one point, and you're going to be able to figure out using algebra what that point is. There's also a possibility that your system could have what we call infinitely many solutions. And so really what we're looking at here is that although this looks like one line, we've had two lines in all of the previous examples. There are two lines here too, but the reason why you can't see two lines is that one is right on top of the other, right? One of our lines here is right on top of the other. And so that means that they have the same equation, and that so no matter what you solve for, you're going to find that at every single point, they are together. They have the same values. So that would be infinitely many solutions. That's going to be two equations that are actually the same. Well, what might that look like? Let's just use a really simple example of a line in slope-intercept form, which is again what you'll learn about in the coordinate plane session if you haven't already done so. Let's say we have y equals 2x plus 4, right? And then you have another line whose equation is, oh, I don't know, 2y equals 4x plus 8. Right? Now, if you wanted to put this second line into slope-intercept form, you would do that by dividing the entire equation by 2. Right? Because for slope-intercept form, you want to get that y by itself. You don't want it to be multiplied by anything. You don't want it to have a coefficient. Right? This number 2 in front of the y is a coefficient. You don't want a coefficient. So you divide every single term by 2, right? Whatever you do to one side, you have to do to both sides, and you have to do it to every single term. And you would wind up with exactly the same equation that you started with, indicating that yes, indeed, those two equations describe exactly the same line. That would be a situation in which you would have infinitely many solutions. All right. But again, the situation that you're going to run into more frequently on the GED math test is one in which you have two what we call distinct linear equations. These two here are not distinct. This one and this one are actually the same. You can see that when you simplify, right? But most of the time you will have distinct, different equations which you will be able to solve. So let's go ahead and take a look at how we do that. Now, there are two ways to solve a system of equations algebraically. And the first way that we're going to look at, we call substitution. And if you remember ever doing this in school, you probably remember doing it by substitution. That seems to be what most people recall. So let's take a look at how that works. So we've got our two equations here. X plus y is equal to 9, and 2x minus 3y is equal to 8. So we're going to go ahead and write out one of these equations. And this first equation that we write out, we are going to solve it in terms of one of our variables. And the one variable we're going to choose here is x. We're going to say, let's get x by itself. Okay, well, how do we get x by itself in this equation? Well, we get x by itself by subtracting y from both sides. When we subtract y from both sides here, subtract y. From the left side, we just have x, which is what we wanted. Subtract y from the right side, we have negative y plus 9, or 9 minus y. It does not matter how you write it. It's exactly the same. Okay? So the beauty of that is that now that we have this expression for x, what do we get to do with it? We get to, I want a different tool there to kind of set this guy apart. Right? Now that we have this expression, x is equal to negative y plus 9, we can take that and plug it into the other equation wherever we see x. So since we have 2x minus 3y is equal to 8, right? Instead of writing x here, we can write negative y plus 9 because we know from the other equation that that's what x is equal to. So 2 times negative y plus 9 minus 3y equals 8. And now we just need to simplify. So what is our next step to simplify here? Since we have those parentheses, 2 times negative y plus 9, we have to make sure that we distribute that 2 over both of those terms. And when we do that, this is what we get. Negative 2y, right? Don't forget that negative sign, plus 18 minus 3y is equal to 8. Next step, right? And so now we're going back to the basics of algebra. So again, if this needs a refresher, check out the algebra session, the GED Life algebra session. And so here the next step is to combine like terms. Get those y terms together. We have negative 2y plus minus 3y, which is the same as plus negative 3y, is going to be negative 5y. We have 5 negative y's there, right? And we've still got our 18. Now at this point, to isolate y, we want to put all of our constants on the same side, subtract 18 from both sides. 8 minus 18, right? And again, really be careful with these signs. 8 minus 18 is going to be equal to negative 10. Okay. And then we've got negative 5y is equal to negative 10. And the final step is to divide both sides by that negative 5. Again, we've got a coefficient here in front of y. We want to get rid of it. So our coefficient is negative 5. That's what we divide by. And y is equal to 2. Excellent. Now, we're not done because we're solving, we want to get the entire solution. This question doesn't just say, what is the value of y if x plus y is equal to 9 and 2x minus 3y is equal to 8? A question could just say, what's the value of y? But if it asks you to solve the system, you're actually going to be solving, again, for that point of intersection. And a point has to have an x value and a y value. Right? This is how we write a point, x comma y. Right? So we know what our y value is. Our y value is 2, and we just need to find out what x is equal to. So to find out what x is equal to, we simply take our y value of 2 and plug it back in to either of the equations. It's going to make sense to plug it into the simpler one, right? Which I would argue is definitely this one, right? So let's go ahead and take our y value of 2, plug it in there, and see what our x is equal to. Well, if x plus 2 is equal to 9, that means that x is equal to 7. So our x value is 7. We put that into our point, and that is our solution. So this is solving a system for the point of intersection, right? And that's always what we're solving for when we solve a system of equations. Algebraically using substitution. Substitution being where we first get one of the variables by itself, right? Isolate, rearrange one of the equations so that a variable is by itself, then take that expression for the variable and plug it into the other one, the other equation. When you do that, what you wind up getting is an equation that just has one variable, and then you know how to solve that. Solve for the one, plug it back into the other equation to get the other. So those last couple of steps where you plug back in to get the other variable are going to be the same, but the way that we get there is a little bit different when we use the other method for solving a system of linear equations, and that is combination. So let's take a look at how we would solve using combination. Also known, just FYI, you may also see this referred to as elimination. And it's kind of nice to think about this as elimination just so that it doesn't get mixed up in your mind with solving for combinations like combinations and permutations, which we'll be looking at later in this session. So what we're doing here is we are taking these two equations and we are combining them in a very particular way. So let's see how we do that. Again, notice we got the same two equations here, so we better get the same solution. We will, don't worry. We're going to get the same solution. But the first step here is to do something to one of the equations, or occasionally both of the equations, so that the coefficients of one of the variables are equal, right? You need equal coefficients in order to make this method work. So again, coefficient being what is the number in front of the variable, by what number is the variable being multiplied. In our first equation, we have just x plus y is equal to 9, right? But in our second equation, we have a 2x. So what we're going to want to do in this situation to get the coefficients of at least one of our variables the same is to just go ahead and multiply that simple equation, x plus y is equal to 9, by 2. Right? Because when we do that, 2 times x plus y is equal to 9, make sure you distribute that 2 out over every single term so that you get 2x plus 2y is equal to 18. So now I've got my x coefficients equal. What can I do with it? Well, what I can do here is I can take that 2x plus 2y is equal to 18, which is the same exact equation as my x plus y is equal to 9. Right? Here's my x plus y equals 9. Here is the exact same equation, just everything's multiplied by 2. Same equation. Okay? But now I can take my other equation, 2x minus 3y is equal to 8, and subtract it. It is totally mathematically legal to subtract one whole equation from another whole equation. So to do that, I just line up my x terms, line up my y terms, and line up my constants. And I can do that any way that I like, as long as one's underneath the other, right? X is under x's, y is under y's, and constants under constants. And I see what I get when I subtract. So just be careful, right? 2x minus 2x is 0. That's the whole point of doing this, is to get those x's to go away, right? So here we've got 0, right? Then when we do 2y minus negative 3y. Don't forget that this is minus all the way across the board. That's going to be the same as 2y. Oops, let me put that y in there. That's really important. That's ugly. Let me start over. I really don't like the way that looks, and I don't want it to be confusing. All right, so let's fix that. 2y minus negative 3y, right? Is equal to 2y plus 3y. You're probably way ahead of me now, right? 2y plus 3y is equal to 5y. Okay, and then the next subtraction that we do is a bit more straightforward, so we don't need to do that out separately. But 2y minus negative 3y is 5y. 18 minus 8 is equal to 10, right? So my x's went away, and now I just have 5y is equal to 10. Oh, that's easy enough. Just divide both sides by 5 to isolate my y, and y is equal to 2. So if you back up the video, or if you just think back to what we did for substitution, you may agree that this method of solving is actually can be quite a bit quicker and more straightforward than solving by substitution. So even though it may not come naturally, it's definitely something to practice, because you'll often find that it might be a faster way to get to your correct answer on test day, which is important. Right? Shaving a few seconds off here and there gives you more time to devote where you really need to think hard about something. So if y is equal to 2, we do exactly what we did before, which is take our y equal to 2 and plug it back in to either of our equations. But again, we're going to plug it into the simpler one, right? X plus y is equal to 9. Okay, if y is equal to 2, then x plus 2 is equal to 9. Right? And, right, so all of those purple equations are the same, and then we're just plugging in our y is equal to 2. So in fact, I am going to adjust this. And y is equal to 2. So I plug that y is equal to 2 in, and again, x, as it was before, is equal to 7, and our solution is 7, 2, point of intersection. Okay. So let's go ahead and take a look at a problem here. Now, as we always do in these recorded lessons, we're going to invite you to pause the video and give this one a try by yourself. Now, what I want to tell you right now is when I solve it, I am going to solve it by substitution. We'll give you a chance to practice both methods. So I am going to solve this by substitution, and I'm going to ask you to do the same thing. So try this one by substitution and see if you can get to the answer doing as little work as possible, because on any standardized test, it's going to help you to see if you can minimize the work that you're doing. So give this one a try, and restart the video when you're ready, and we'll review it together. So welcome back. Let's see what we want to do here. So again, I asked you to solve this by substitution. You totally could solve it by combination as well, and if you haven't tried that, then definitely do, to kind of show yourself that both systems work, and it's up to you to pick the one that's best and easiest for you. We want where these lines intersect. That means that we need to solve our system, either by combination or by substitution, because we're working with algebra in this particular session. So here's our one equation, x minus 2y is equal to 4. What we do here if we're solving by substitution is go ahead and get that x by itself. And in this case, because we have x minus 2y, we are adding 2y to both sides, right? Plus 2y here, plus 2y here. We get x is equal to 2y plus 4. So then we have an expression for x that we can go ahead and plug in to our other equation, which is 6y plus 5x equals 4. And you can see that it makes sense to work with this equation first because it's so much simpler. It's so easy to isolate x here. Isolating x or y here would be a bit more of a nuisance because each of x and y has a coefficient, so that would involve an extra step. So we isolate x in the easier equation. X is equal to 2y plus 4, and then we can go ahead and plug that in to our 6y plus 5x equation here. So x is equal to 2y plus 4. That means that when we do our substitution, we have 6y plus 5 times 2y plus 4, because that's what x is equal to 4. Okay, good. Now, go ahead and distribute 5 over the 2y and over the 4. And we're going to get 6y plus 10y plus 20 is equal to 4. Combine like terms. 6y plus 10y is 16y. Subtract 20 from both sides. 6y is equal to, 16y. 6y plus 10y is equal to 16y. Subtract 20 from both sides, and 16y is equal to negative 16. Now again, if you prefer to keep things positive, you could say, if you had 16y plus 20 is equal to 4. Another way to do that would be, and you might find this arithmetic easier, and you do have a choice. You might say, oh, well, I think what I would rather do is subtract 4 from both sides so that my constant remains positive, and then I'd have 16, right? But then I would have to subtract 16y from both sides as well, right? And then if I subtract 16y from both sides, I'd still wind up, right, one way or another, I'm going to wind up with something that's negative here, but I would get 16 is equal to negative 16y. So you can do this whichever way makes the most sense to you. Either way, when you solve, you're going to get y equal to negative 1 when you do your final division. Okay, on this side we would divide by negative 16. And the way that we did it, and so 16 divided by negative 16 is just negative 1. And the way we did it over here is that we divided both sides by 16, and negative 16 divided by 16 is negative 1. So divide by negative 16. No, divide by 16 on this side. Let's back that up. Divide by 16. Divide by 16. Right, bottom line is whatever your y is multiplied by, that's what you divide by. We get y is equal to negative 1. Now, don't forget that you can use the answer choices. And so this is really what I was referring to when I said make your work as easy as possible. What you know when you see that y is equal to negative 1 is that, okay, well, if you're solving for this solution, this is what your solution is going to look like. Something, comma, negative 1. Well, guess what? Only one of the answer choices has negative 1 in that y spot. So A has to be correct. And you don't have to do that last little step of plugging in negative 1 for y back into one of these equations to get the value of x. Right? And if you do, it's a good check. You can make sure that it's equal to 2 and that you're doing your work correctly, but you do not need to do that on test day if that y value matches only one of the answer choices. Okay? So good work with substitution. Let's give you a chance to try the next question using combination. Right? So again, this one combination where we want you to make the coefficient on one of these variables equal. Right? So are you going to make the coefficient on the, oh, wait a minute. Combination tells us to make the coefficient equal on one of our variables, but we've already got y here and y here. So, okay, what's that going to look like when you do combination? Well, the other thing with combination is not that we need to have the variable with the same coefficient, but that we line them up, line our equations up so that y is under y, x is under x, and constant is under constant. So give that a try here and see how it works out. It might look a little different, but don't let that throw you for a loop. Give it a try, pause the video, come back when you're ready, and we will go over it together. Okay, so here, again, your y's already have the same coefficient. So really what we need to do is just rearrange the way the equations are written so that our y's and our x's and our constants are in the same place. So if we want to match up our first equation, which is our y equals 3x minus 15, with our second equation, which is x plus y is equal to 13, that means we want to get y by itself on the left-hand side. So to do that, we're just going to subtract x from both sides, right? We're going to get that x out of there so that I have y by itself. Okay, and that's going to be y is equal to negative x plus 13. And then I can line up my other equation directly underneath that equation. Right, so y is equal to 3x minus 15, and y is equal to negative x plus 13. Let's go ahead and get those both down. And now I can subtract my equations. Now, we did say earlier, when I introduced combination, I said you're going to add or subtract the equations. So here's what I want to show you right here. We can either subtract the equation that we have here, y is equal to negative x plus 13. But also note that we can take that negative and distribute it over each of our terms. And so if we do that, here's what it's going to look like. That second equation is going to become, and let's just go ahead and do this distribution. Right? It's going to be, oh, I want my arrow back. It's going to be negative y is equal to, negative times the negative x is going to be a positive x. And negative times a positive 13 is going to be a negative 13. If you distribute that negative over all of your terms, now when you look at your y terms, you have a positive y here and you have a negative y there. So what do you need to do to a positive y and a negative y? What are we now going to do to these equations to get the y's to go away? Well, in this case, because now the coefficients are actually opposite. Up here, the coefficient is plus 1, and down here, the coefficient is minus 1. We're actually going to add the equations to get our y's to go away. So if you would always rather get the coefficients exactly the same and subtract, that's fine. If your brain works better when you say, no, I'd rather have the coefficients be the opposite and then add the equations, that's fine too. These are two ways of accomplishing the same goal. And we just want to make you, aware of different ways that you can do it depending on what works best for you. Now, when we add these y's together, we know we're going to get 0. Y plus negative y is just equal to 0. And then we add our 3x and our x, and that's 4x. And our negative 15 plus negative 13 is going to be negative 28. Now, this looks a little different because right now we don't have our variable on one side and our constant on the other. That's fine. We can get our variable on one side. Let's just bring the 4x over by subtracting 4x from both sides. And again, you could do this either way. You could say 4x is equal to positive 28, or you could say negative 4x is equal to negative 28. Either way, your solution is going to come out the same. If you like to keep the x on the left-hand side, you subtract 4x from both sides. And now to finally get our solution, we just divide both sides by negative 4, and x is equal to 7. So x is equal to 7 here, so we know that our solution is going to look like this. Right, so here our solution will be 7 comma something. And here we don't have the luxury of just saying, oh, well, it's got to be answer choice, whatever, because 2 of our choices have that 7, right? A and D are definitely out because they have the wrong x value. but both B and C have x is equal to 7, so we are going to have to plug x is equal to 7 back into one of our other equations to get the value of y. And of course, it makes most sense to plug x is equal to 7 into the simpler of our two equations, this one here, right? X plus y is equal to 13. If 7 plus y is equal to 13, then y must be equal to 6. And so our final answer is 7, 6, and that's answer choice B. So that is our point of intersection, 7, 6. So good work with combination. You know, think this over. Which way to solve do you prefer? Try practicing both of them and really get good at both of them so that you're ready to just think on the spur of the moment on test day, okay, how do I want to solve this? Put yourself in control of this test and of the processes and of all the work that you're going to do. Let's take a look at one more systems of equations question. Number 3. So here we are looking for, this is a little bit of a different situation because here they're not asking us to find the intersection of two lines. Here the test maker is saying, what is the equation of a line that intersects with this particular line that we are given? What's the equation of a line that intersects with this line? So this is a question where a little bit of critical thinking is going to go a long way. So before you pause here, I'd like you to think about, well, what does it mean, again, that one line intersects with another line? They have to have a point in common. And what do you know about the slope-intercept form of a line? Right? This is slope-intercept form. Okay, so what do you know about that? And, you know, if at this point you're still hazy on that, that's absolutely fine. You know, check out the coordinate plane session. And when you come back after unpausing the video, we'll discuss it. So good luck, give it your best shot, and we'll see you shortly. Welcome back. So you know that the point of intersection, that where the lines intersect, they are meeting at one particular point that they have in common. They have one point on the line that belongs to both lines. And so we're looking for a line in the answer choices that we know shares a point with the line in the question stem. This y is equal to 4x plus 2. And you may recall that when we have slope-intercept form of a line, right, y equals mx plus b, b is the y-intercept, right? Y and x are just the coordinates of any point on the line. M is our slope, but b is our y-intercept. This is our y-intercept. And at the y-intercept, what do we know? Well, even just going by the name of it, the y-intercept is where the line intercepts or crosses or meets the y-axis. And if you are ever any place on the y-axis, and let's just draw up a really sloppy, quick little xy plane here, right? This is our origin. It's 0, 0. Here's the x-axis. Here's the y-axis. Okay, this line is crossing the y-axis at number 2. So right here. Well, what are the coordinates of that point? Coordinates of that point, because it's on the y-axis, it hasn't gone anywhere on the x-axis. Its x-coordinate is 0. So that point has the coordinates 0, 2. Right? So for this line, the y-intercept is 0, 2. Now, if you look at the answer choices, right? So there's some important logic behind this, but the work that you're doing is very minimal if you understand the logic. Right? Because if you look at these answer choices, 2 of them are in slope-intercept form. Right? Only choices B and C are in slope-intercept form. Now, there's only one answer here. There's one correct answer, so there is only one line that intersects the line that we were given, y equals 4x plus 2. And since we have this line here, answer choice C, that is in slope-intercept form and also has a y-intercept of 2, that means that answer choice C also has the point 0,2 in its graph, which means that answer choice C is the line that intersects the line that we were given in the question stem. So that's it, right? That's how simple you can make this. But again, you can see that there's quite a bit of understanding what these different equations mean and how they relate to the graph. And that's why, I mentioned earlier that, yeah, if you still feel a little rusty with coordinate plane, definitely review some of that material, because it's going to help you on questions that, have an algebra aspect and have, a geometry aspect as well. If you would like, for an exercise, try to determine why none of these other lines, none of the line in answer choice A, the line in answer choice B, and the line in answer choice D can't intersect the line y equals 4x plus 2. And if you think back to something we discussed earlier with what it means for two lines to have no solution, that might give you a clue. And if you're wondering about that, feel free to follow up with us in the mailbox, which will give you the address at the end, but hopefully by now you know it, gedhelp@kaplan.com. So let's go ahead then and move on to our next advanced topic, which is factorials and related formulas and the kinds of problems that require you to use factorials. So factorial, right? It's easy to demonstrate, hard to describe in words, but we do a good job here. It is what you get when you multiply an integer by all the positive integers smaller than it. So what does this mean? Well, here's an example. The factorial of 3 is 3 times 2 times 1, right? You just go down integer by integer until you get to 1, multiply them all together, and that is your factorial. We have a symbol for factorial. It is the exclamation point. So, when you see 5 factorial, it's not like 5! It is 5 times 4 times 3 times 2 times 1. And you could multiply that out in your head or on paper or using your calculator. But the nice thing about factorials is that your calculator will actually do factorials for you. And we'll talk about how to do that. If you're not already familiar with that TI, it's the 30, TIXS30XS, that calculator that you'll be using on test day. We'll show you how to calculate factorials and combinations and permutations using your calculator. So let's take a look at some of the applications of factorials. You have your combinations. So a combination is the number that you get that represents how many different ways. If you have a large group of items, and by large I just mean larger than the subgroup that you're going to pick out of it. If you have some group of items and you want to pick some smaller group of items out of the larger group, combinations is just how many different small groups you can make. Right? How many ways are there to pick a small group out of a big group? And the crucial distinction between a combination and what we're going to define next, which is a permutation, is this phrase here: the order doesn't matter. And obviously we're going to look at a couple of examples to help you to recognize that difference between order doesn't matter and order does matter. Now, for combinations, there's a formula where n is equal to the number of items in the large group and r is equal to the number of items in the smaller group. Actually, before we get to permutations, let's just define that up top, or actually to the side here. N is equal to the number of items in the large group. R equals number of items in the small group. So that's what the n and the r stand for in this formula. So you can imagine that if you have an n and an r and they're relatively small, you could actually write out this whole formula, and you'll find that when you do, a whole bunch of stuff is going to get canceled out, and the arithmetic isn't as ugly as you might think. But again, you don't have to do that on the GED math test because your calculator can do it for you. Let's introduce the permutation formula. The difference between permutations and combinations, and the way you know whether you're going to pick NCR on your calculator, which is combinations, or NPR, which is permutations, is whether the order matters or not. So if, when you're choosing this small group out of the larger group, there's some kind of order or assignment of the items or people or whatever they may be, if there's order or assignment to specific positions, then order matters, and then you're dealing with a permutation. Permutation's formula, as you will see, looks a lot like the combinations formula. The only thing that's missing is that r factorial in the denominator, and you don't have to, I mean, it's kind of interesting to note that they're similar, but you don't really have to think about, oh, why would that be the case, right? That's, not outside the realm of what you need to master for the GED math test. You just want to keep in mind combinations is your C, order doesn't matter. Permutations is your P, order does matter. Now, you can see that these formulas use factorials. And so your calculator can do factorials, your calculator can do combinations and permutations. Now, a related concept to all of this, this idea of counting when you have a lot of possibilities, how do you count them, is the idea of the fundamental counting principle, which we will also talk about. But first, let's show you how you're going to use that calculator to do these calculations. So you have to understand what n and r stand for. And again, the n is the larger number and the r is the smaller number. Right? So in this particular example, let's give you a couple seconds to go ahead and read through this. The question you need to answer for yourself, if you were answering this question on the GED math test, is what is my n, what is my r? Well, let's say 3 questions. What is my n, what is my r, and does the order matter? In this case, Vladimir is choosing 3 out of 6 students, but there's no assignment, there's no order. He's not going to pick a student who's like #1 student and a student who's #2, or one student's going to be the captain of the team or anything like that. It's just 3 students. So there is no ordering here. Order doesn't matter. It's just who are your team members. So that means we're going to be using combination, and the total number of items is 6, and the number that we're choosing is 3. So here's what we're going to do. You're going to go to your calculator, and you're going to first pop in your 6. Right? This is the first thing. You plug in your 6 first. This is number 1. Then you come over here to the probability key. This is number 2. Number 3 is you select NCR from the list. Your list will include NCR and PR for permutations and factorial. This is what you're going to do third. Just pick NCR, and then fourth, put in your 3. Once you select NCR, you'll hit enter to actually select it. Then you plug in your number 3, then you hit enter again, and it's going to pop out your answer, which is 20. And you never have to actually use that formula. So definitely give this a try with your calculator. Make sure that you understand how that process works so that it's something that you don't have to think about or try and remember on test day. Okay. So let's go ahead and take a look at this last concept, which is the fundamental counting principle. So if you have a bunch of different choices that need to be made, or if you have different events or positions in a given situation, and we'll look at a few situations so that you can see how this works. The way that you're going to calculate this is by looking at each choice that's going to be made, or each position that has to be filled, and figuring out how many things can go in each spot. Then you just multiply them all together to get your actual number of possibilities. And so when you see a question involving permutations, if the question has you selecting some smaller group, you're going to use your NPR in your calculator. If you are selecting a smaller group, you're going to be using NPR. But if you're just figuring out how many ways something can happen, how many different ways or how many distinct ways something can happen, then you're going to be using the fundamental counting principle. And here are your steps. Draw blank for each choice, or position, or event, or whatever it might be. Fill in the number of possibilities for each one, and then just multiply them. So let's go ahead and look at an example here. A chef is making soup with 5 ingredients. And for each of those ingredients, the chef has different choices. So we want to know how many different combinations of ingredients the chef could put into the soup. Okay, so think about that. How many different combinations of ingredients? Think about how you want to set this up. Give it a try. Get your calculator out in case you don't already have it out. And then come back when you're ready and we will review. When you read through this problem, you can see that we've got, okay, meat, vegetable, noodle, broth, and spices. And you can write them all out and label them however it makes sense to you. But this is definitely a fundamental counting principle situation, right? We've got 5 different choices that need to be made, and we have a number of possibilities for each choice, right? So we're taking one of 4 different meats. Okay, so we're going to put 4 in for meats. One of 4 different vegetables, so we're going to put 4 in for vegetables. One of 4 different types of noodles, 4 different types of broth, and 4 different spices. And boom, that's it. Right, so the way that you're going to calculate this is simply by taking 4 and multiplying it by itself 5 times, 4 to the 5th power. And when you punch that into your calculator, that is going to be 1,024, answer choice C. So as long as you recognize a question that is asking you to apply the fundamental counting principle, these questions that can be very perplexing if you don't have the right tool become pretty straightforward when you do have the right tool and you know how to use it. Okay, so let's take a look at the next couple of situations and give you an opportunity to figure out what is the right tool and use that tool to solve the next 2 problems. So let's do number 5 first. I'm not going to say anything about this one, just give you a chance to think it through. So go ahead and pause the video and come back when you're ready. So here, welcome back. Here, Soraya has 6 tasks that she has to do at work, but she only has time to complete 4 of them, and she needs to decide in what order to do them. This is a pretty realistic scenario. I find myself in the situation all the time where I'm like, okay, I have to do, you know, RSTUVXY tasks, but I know I don't have time for all of that. How should I prioritize my task? So what you can recognize in this problem is that she has 6 tasks total. She's only going to be able to do 4 of them. And she has to decide in what order to do those tasks. So those 3 characteristics